Most engineers believe this. If a protection CT has a higher rated burden than the connected burden, or if its accuracy limit factor is too high, it must be better. But in reality, this misconception can create a serious safety hazard. Let me show you why. Consider this simple protection circuit. A numerical relay, with a burden of 0.05 voltamp, is connected to a current transformer. The CT has a ratio of 100 to 1 amp. It has a rated burden of 10 voltamp, protection class 5P, and an accuracy limit factor of 20. The CT winding resistance is 0.7 ohm. The secondary lead resistance is 0.1 ohm. So the total connected burden, including secondary leads, is only 0.15 voltamp. At first glance, this looks excellent. You might be thinking, this is a perfect setup. The CT rated burden is above the connected burden, so there is no problem at all. But this is where the mistake starts. Before we move further, a quick reminder about protection CTs. The accuracy limit factor, or ALF, defines how far a protection CT remains accurate at the rated burden. Beyond this point, CT saturation is expected. With this in mind, let's come back to our example. In this case, an ALF of 20 is valid only at the rated burden of 10 voltamp. But here, the CT is not operating at 10 voltamp. It is operating at only 0.15 voltamp. So the CT behaves very differently. With such a low burden, the effective accuracy limit factor increases significantly. At lower burdens than the rated burden, the increased ALF can be approximately calculated using this formula. This gives an effective ALF of about 250. This means the CT will not saturate until well over 250 times rated current. Many engineers would say, this is an ideal condition. The CT will never saturate during faults. But this misconception hides the real risk. Here is why. Most numerical relays can withstand about 100 times rated current for 1 second. That means the relay can tolerate a fixed amount of thermal energy. 100 squared for 1 second. But in this case, during a severe fault, for example, at 25 kiloamp fault current, the relay sees about 250 times rated current. Because the CT does not saturate. Applying the I2T limit, the safe time becomes much shorter. The calculation shows the relay is safe for only about 0.16 seconds. If the fault is not cleared within 0.16 seconds, the relay input circuit may overheat and get damaged. When that happens, the CT secondary may become open-circuited. And this is one of the most dangerous conditions in any protection circuit. If the CT secondary opens while primary current is flowing, very high voltage appears across the secondary. Not a few volts. It can reach thousands of volts. This single design mistake can cause permanent relay and CT damage, insulation breakdown, arcing and fire inside protection panels, and severe electric shock. This is no longer just a CT or relay problem. It is a plant and people safety problem. Now let's look at the same example, with the protection CT designed correctly. The relay is the same. The wiring is the same. But this time, the CT rated burden is selected as 2 voltamp, not 10. The protection class is still 5P, but the rated ALF is 10 instead of 20. The actual connected burden is still 0.15 voltamp. Now the CT is operating much closer to its intended design point. With this selection, the effective accuracy limit factor increases only moderately, to about 32. This means the CT will reproduce current accurately up to about 32 times rated current. Beyond that point, the CT begins to saturate. Now apply the same I2T rule. At 32 times rated current, the relay thermal limit allows about 10 seconds. That is a much larger safety margin. The relay, CT, plant and people remain protected. So the key lesson is this. A protection CT that is too oversized can be just as dangerous as one that saturates too early. If the CT operates far below its rated burden, or if the actual accuracy limit factor is too high, the CT itself becomes a hazard source. So an oversized protection CT is not automatically better. In many cases, it is worse. It is therefore obvious that every protection CT must be precisely dimensioned. This is essential to ensure the CT delivers the desired response, while also protecting the plant and the people. Hope you will take care of this in your protection designs. Thanks for watching.